On the 9th of March 2025, a camera 600 meters beneath the South Atlantic recorded the first confirmed colossal squid alive in its natural habitat. It was 30 centimeters long, almost completely transparent, about the length of a school ruler. Its common name is built around size. Adults are estimated at around 7 meters and 500 kilograms, the heaviest invertebrate on Earth. The animal in the light was a juvenile, and nothing about it looked like the creature the name promises. The real surprise is what that footage did not contain. Adults have been seen before dying at the surface, tangled in fishing gear, hauled up on long lines. Dead ones sit in museum collections. What has never been seen is an adult alive, at depth, where it actually lives. So the adult we imagine comes from a different kind of evidence entirely. Bodies recovered by fishing boats, larger beaks found inside predators, hooks examined on laboratory tables, enormous eyes measured after death. No camera has watched a healthy adult move through its normal habitat. Before we rebuild that adult out of fragments, picture the colossal squid in your head right now. Hold on to that image. For the next 100 years, the species arrived in pieces. Mesonychoteuthis hamiltoni was named in 1925. The most common piece was a beak. Colossal squid have hard, parrot-shaped mouthparts that resist digestion, so their beaks accumulate in the stomachs of the animals that eat them. Sperm whales. Seabirds open a stomach, and you find the parts of a squid that survived the meal. That is a strange way to meet an animal. You learn its size from a fragment, and you learn roughly where it lives from whatever ate it. A beak is real evidence, and its dimensions help researchers estimate the squid that carried it, but that is still an estimate, not a body on a scale. It cannot show how the animal moved, how it caught anything, or how long it lived. And because a whale may travel a long way after feeding, a beak in a stomach tells you the two animals crossed paths somewhere, not where the squid spent its life. The beak survived because it did not break down during digestion. That made it the most common evidence and forced scientists to reconstruct an enormous animal from one small surviving part. Occasionally, something larger arrived. In early 2007, a long-lining vessel called the San Aspering was fishing for toothfish in the Ross Sea. 1,500 meters down, a colossal squid took hold of a toothfish already hooked on their line and did not let go. As the line came up, the squid came with it. By the time it reached the surface, it was dying. It went onto the scale still frozen, with ice inside it, and read 495 kilograms. Te Papa now puts the animal itself closer to 470. Hold on to that squid. It is going to matter twice more before this video ends, because several of the hard numbers in this story come from that one body. 7 years later, the same vessel returned with another. In early 2014, the San Aspering came back with a second colossal squid, around 350 kilograms, and missing its long feeding tentacles. It was fresh enough that Te Papa examined it publicly later that year. Read those two encounters carefully. Both animals reached science through the toothfish fishery, not as healthy adults moving through the deep. Every clear look humans have ever had at an adult ends the same way, at the surface, on a deck, or in a museum. Not one has been watched alive, at depth, doing whatever it normally does. So when you picture an adult colossal squid hunting in the dark, that picture has no footage behind it. It was assembled. When the animal finally appeared alive, nobody on the ship knew what they were looking at. Sebastian was not searching for a colossal squid. The vehicle was diving near the South Sandwich Islands from the research vessel Falkor II on an expedition surveying the deep ocean broadly for marine life. So when a small, clear animal drifted into its lights at 600 meters, the team did not begin with an answer. They began with an identification problem. It was nearly a foot long and so transparent that the light passed straight through it. You could see structures inside that a solid animal would have hidden. That was the difficulty. Juvenile glass squids are genuinely difficult to identify from video, and several species look alike at that age, including one, Colossal glacialis, that lives in the same water and looks much the same when young. The hesitation matters more than it sounds. It would have been easy, on a ship in the South Atlantic, to announce a colossal squid immediately. The animal was in the right ocean, at a plausible depth, in a family that contains the species. Instead, the expedition treated its own footage as a question and sent it to independent specialists. The video went to Dr. Kat Bolstad and Dr. Aaron Evans, two glass squid specialists who had not been on the expedition. Working from the footage, they identified it as a juvenile colossal squid. The clearest visible clue was the hooks. Colossal squid carry hooks partway along each of their 8 arms, one of the features that separates them from their look-alike relatives. On this small transparent animal, those hooks could be seen. That is the verified result, and no more. A 30-centimeter juvenile, alive at 600 meters near the South Sandwich Islands, identified from the footage by independent specialists. They had found the right species, but not the adult behind the name. The footage fixes one point in the life cycle. It does not show how a half-ton adult moves, hunts, or avoids being eaten. Now divide what we know about the adult into 3 columns: measured, inferred, and never observed. Start with measured. That squid from the 2007 longline gave us 2 numbers, 495 kilograms as it came off the scale frozen, and roughly 470 for the animal itself. Either way, it is the heaviest colossal squid on record, which makes this species the heaviest invertebrate ever documented. That body also supplied intact hook clubs and the preserved eye that made the scale of this animal's vision real. Now the inferred column. Some of the beaks recovered from whale stomachs are larger than the beak of that same animal. Bigger beak, bigger squid probably. Nobody has weighed one of those. The larger animals are an inference from a hard mouthpart, not a number from a scale. The 7-meter figure works the same way. It is an estimate built from specimens, from beaks, and from proportions. It is reasonable. It is not a measurement of a living animal. Then there are the weapons. On the 2 long feeding tentacles, each club carries between 22 and 25 hooks. Researchers at Te Papa in Wellington examined those clubs and found that the hooks swivel. They move through a wide arc rather than sitting locked in place. That is a real finding, made on a real specimen, on a table. It is also worth pausing on how unusual that equipment is. Most squid catch things with suckers. A sucker seals against prey and grips by pressure. These hooks pierce it and rotate in their sockets, and the difference is visible on any preserved specimen. And that is where the 3rd column starts. The hook itself belongs in the measured column. Control of that hook belongs in the unobserved one. The hooks move on a dead animal in a laboratory. What a living adult does with them in the deep has never been watched. And there is the transparency. The juvenile that was filmed was see-through. Adults are not. They lose that clarity as they grow. Why and when and how fast are open questions. There is no observed growth curve for this species. Nobody has followed one from a 30-centimeter juvenile to a near half-ton adult. Not even close. Consider the size of that gap. At one end, a transparent animal the length of a school ruler, filmed alive. At the other, roughly 470 kilograms of opaque squid, dead on a scale. Somewhere between those two is an entire life, a change in body, in color, in depth, in what the animal eats, and what can eat it, and no camera has recorded that transformation. We have living footage from one juvenile stage and dead or dying evidence from large adults. The sequence connecting them is missing. So the animal in your head, the enormous dark shape with the swiveling hooks, hunting in the black, is assembled from a preserved body, a set of beaks, a laboratory measurement, and a reasonable guess. The eye creates a different question. These animals carry something the size of a football in the head. Te Papa puts a colossal squid eyeball at around 27 centimeters across roughly a soccer ball, and that is the scale the later vision study worked from. When the second female was examined in 2014, her eyes measured 37 centimeters across, and Te Papa called them the largest animal eyes ever found. The two figures may not describe exactly the same anatomical boundary, but both lead to the same conclusion. Giant and colossal squid sit alone at the top of that record. Their eyes approach 3 times the diameter of any other animal alive. Eyes are expensive. They cost energy to build and energy to run, and in an animal living in near freezing water where food is scarce, that cost has to buy something. The obvious guess is that it buys hunting a bigger eye to find prey in the dark. But the mathematics of that is unconvincing. For small prey close by, making the eye even larger adds surprisingly little. In 2012, a modeling study published in Current Biology asked what an eye on that scale could do that an ordinary deep-sea eye could not. The model pointed to a possible answer, detecting a large object moving at a distance, in water, by the faint bioluminescent glow that its movement stirs up. Deep water is full of small organisms that flash when they are disturbed. A big animal swimming through them lights a trail. A small eye cannot resolve that at range. A very large eye might. The predator at the center of that model is the sperm whale, which dives to these depths and eats colossal squid in quantity. That is why the beaks pile up in whale stomachs in the first place. So the proposal is this. The extreme size of these eyes may not be mainly about finding prey. It may help the squid detect an approaching whale before it closes the distance. I want to be careful here, because this is exactly the kind of idea that gets repeated as fact. It is a model. It is a well-constructed argument about what large eyes are physically capable of. No one has ever watched a colossal squid detect an approaching sperm whale, or react to one, or avoid one. The eye is real and measured. What it is for is a proposal.
That 2007 squid reached the surface holding a toothfish. Antachus holding a toothfish. But one dramatic encounter cannot tell you what a species normally eats. The broader diet evidence is less cinematic. Ask most people what a 500 kilogram squid eats, and they will say something large. Other squid, probably. Big things in the dark. Researchers assembled the available diet evidence from recovered animals and feeding encounters. In that dataset, the identifiable prey was dominated by midwater fish. Neither cephalopods nor krill were recorded. The sample is limited. Particular records particular parts of the Southern Ocean, so it cannot define the species' complete diet. But it does not support the squid-eating squid diet. Those hooks might make you imagine. The same dataset did not record colossal squid evenly across the Southern Ocean either. Observed abundance was highest in the Indian Ocean sector and lowest in the Ross Sea. But much of that distribution evidence also comes from fishery encounters, which means the map reflects two things at once, where squid were recorded and where fishing effort created the opportunity to record them. A sparse area may hold fewer squid, or it may hold fewer observers. This data alone cannot fully separate the two.
Think about the image you were holding at the start. Almost certainly it was large and dark and moving. Almost certainly it had a sense of menace to it. Now rebuild it, using only evidence that actually exists. A beak in a whale's stomach. One animal dying on a longline in 2007, holding a toothfish it would not release. A second female recovered by the same vessel in early 2014. Eyes bigger than a football, measured after death. Hooks that swivel on a laboratory table. Every single one of those is real evidence. None of them is a living adult colossal squid, at depth, being itself. What we have actually watched, alive, in its own habitat, is the length of a school ruler and transparent enough to see through. That is not a disappointing result. It is an honest one. The 2025 footage did not close the colossal squid story. It showed us precisely how much of that story we had written ourselves. And it is not clear when the rest arrives. Schmidt Ocean plans more Antarctic research over the coming decade, but the deep Southern Ocean is enormous. Confirmed encounters are rare, and no expedition yet has a reliable place where a free-swimming adult can simply be put in front of a camera. So the century of not seeing it may not be over. We have seen it begin. We have never seen what it becomes. One expedition. Would you send it straight after a free-swimming adult, or back to the depth where this juvenile appeared, to look for the missing growth stages? If you know someone who saw the 2025 footage and assumed the colossal squid mystery had been solved, this is the video to send them.